Okay, so in the honors course, we extend complex numbers by learning about modulus and quotients. So you'll be able to find the conjugate of a complex number because we're going to be able to use this when we divide, because you don't really divide complex numbers. So the conjugate of a complex number is, if you're given the complex number a plus bi, the conjugate keeps the real part the same, okay? And then it takes the opposite of the imaginary part, and that's it. So when you divide, there's a rule, just like with square roots, that you cannot leave an I in the denominator. So in order to rationalize a complex number, you are going to multiply by either the conjugate, or if it's just a single term, you multiply by the I on the top and bottom. Okay, so I'll show you how to do that. So on example 1, we're just going to state the conjugate. So remember, the real part stays the same, and you take the opposite of the imaginary part. That's it. B, there is no real part, so the opposite of the imaginary part, and you don't have to put the plus there, I just wanted to emphasize it. And C, keep the real part the same, and take the opposite of the imaginary part. Alright, so on example 2 and 3, these will say simplify, they won't say divide. And so you're like, oh, well, 3 over 4 is simplified. You can't reduce that. But remember, the rule is you can't have an I in the denominator. So since this only has one part, the imaginary part, we only have to get rid of the I. And so magically, it works out if you multiply the top and bottom by I, because that's like 1, then it will. So let's do some math though. 3 times I stays. And then 4, I times I is I squared. And so you always have to remember that I squared by substitution is -1. So we get 3I over -4. And that's a great answer. Sometimes you'll see the negative in front, you'll see the 3/4 together, and you'll see the I next to it. It really is just a preference, but know that those are both equivalent. And example 3 has a complex number in the denominator. So this is when you need to multiply by the conjugate. So 4 plus 2i, and then to be fair, you have to do it to the numerator. These are going to be a little longer, but not terrible. So in the numerator, you're going to distribute. So 24 plus 12i. In the denominator, you're going to double distribute, so FOIL. So 16 plus 8i minus 8i, and then minus 4i times i. So what you should notice is these two middle terms should cancel out. That's why we do the conjugate. -1 by substitution. So -4 times -1 is plus 4. So on the bottom we have 16 plus 4. On the top we had 24, that got a little stopped, plus 12i. And it looks like it's done, but if you look at all three terms, we can divide by 4. So you do that by reducing. So 6 plus 3i, divide that by 4, and then these have to be all 3, so we're done. So if you can reduce, you need to. Now, the second thing that we talk about is the absolute value of a complex number, which is also known as the modulus. It's just a fancy way to say that. I don't know why, but that's what it is. So the absolute value or modulus of a complex number is based off the Pythagorean theorem. So when you graph complex numbers, it looks just like the real plane, except the x-axis is called the real axis and the y-axis is called the imaginary. But it's still in that same order, like x, and fake y. Okay? So it makes a right triangle, and you can see it fits with the Pythagorean theorem. All right. So find the modulus for 5 minus 12i. So you just have to remember that modulus is the absolute value. So a is the real part, b is the imaginary part. So we've got a squared, and then b is -12. So we get 5 squared, 12 squared, And then if you can break these down, you need to. The square root of 169 actually comes out nice, and it's 13. So there's nothing to break down. We actually simplified it. The modulus here, so A is 3, B is 6. So 3 squared. Since these are positives, I don't really need that parenthesis. So 9 plus 36 is the square root of 45, and I do need to break that down. So 3 is single, 3 is double, 5 is single, so 3 root 5. Typically you don't want a decimal. If this was an application, you certainly would. Okay. All right, so give dividing and absolute value a shot.